Hi guys, and welcome to week 2 of distance learning for college trigonometry. We are now starting section 5.3 where we get to solve trig equations. Okay, so a lot of you who really do like that algebra component will really like this section. We are solving equations. One of the things that you will need in order to accomplish solving trig equations is a copy of your unit circle. If you do not have a copy of your unit circle at home, like a paper copy, there is a visual of the unit circle in the back cover of your textbook. So if you do have your textbook at home, go ahead, flip that back cover, and you will find a copy of the unit circle. Let's go ahead and start solving some trig equations. Notice that what they're having us do is to find all of the solutions that fall between 0 and 2 pi. So remember, our unit circle does run from 0 all the way around the circle. You get to 2 pi. Remember this interval notation from college algebra. If it is a squared bracket, that means it's included. If it's rounded, it's not. And the reason why they could not have both of them included is because 0 and 2 pi are at the exact same location on a unit circle. So what that means is if you end up at that point, you will use the 0 as it is included, not the 2 pi. Okay, let's go ahead and do this. So what you want to do is isolate the trig function, and that's what it's saying. Your preliminary goal is to isolate the trig function. So anything that is not sine of x needs to move over to the other side. So step 1, I would go ahead and add 1 to each side. That would leave me with 2 times the sine of x equals 1. I need to isolate the trig function. So this is 2 times the sine, so I'm going to go ahead and divide. So I have the sine of x equals 1/2. Remember, the sine is the y value. So what this is actually asking is where on the unit circle, from 0 all the way around to 2 pi, is the y value equal to 1/2, because that's what your solution is. That's what x would be. So x equals, remember your y values, I'm looking for 1/2. So it's a positive, so it's up above the x-axis. Oh, y is 1/2 at pi over 6. And you can go all the way around the unit circle. So I'm looking at all the y's. Oh, y is 1/2 at 5 pi over 6. Now as I go here, notice all of my y values end up being negative, so I would only have these two solutions right here, pi over 6 and 5 pi over 6. Those are the two x values within the domain of 0 to 2 pi, meaning staying within the unit circle, where the sine, which is the y value, equals 1/2. See, kind of fun, isn't it? Okay, let's try this one. Again, preliminary goal, you got to isolate the trig function. So if I minus 1 over 2 times the cosine of x, 0 minus 1 gets me to a -1. Divide both sides by 2. So I have my trig function isolated. That means it's time to go to the unit circle. Cosine is the x value. So what this is saying is where on the unit circle from 0 to 2 pi is the cosine, or the x value, -1/2. And that's what we're looking for. So if I look at the x value, I'm looking for a -1/2, oh, right here. So 2 pi over 3, x equals 2 pi over 3. And we'll keep looking. Where is the x value, -1/2? And I found another one right here, 4 pi over 3. So x equals 4 pi over 3. My x value, which tells us if you're going to the right or the left, is negative. So I know I won't have any values on the right side of the graph. I would just have them going over to the left. And again, I did find two solutions, one in quadrant 2 and one in quadrant 3. Your solutions to this equation would be x equals 2 pi over 3 and x equals 4 pi over 3. Let's go ahead and do another one. If I want to isolate the trig function, that means I want the secant of x alone. So if I add 2 over, secant of x equals 2. Now remember, the secant is the reciprocal of the cosine. So if the secant is 2 over 1, that means the cosine of x would be 1 over 2. Okay, so again, I took the minus 2, I added it over. That's how I got a positive 2. Secant, the secant is the reciprocal of the cosine. So if the secant is 2 over 1, then the cosine is 1 over 2. Knowing this, it's time to go to the unit circle. Where is the cosine, which is the x value? Where is the x value equal to 1/2? Now, this time we're looking for positive x value, so I'm going to stay on the right side of the unit circle. Here is a 1/2 at pi over 3. Here is a 1/2 at 5 pi over 3. So your solutions are x equals pi over 3 and x equals 5 pi over 3. Those are the two places on the unit circle where the x value was 1 over 2, meaning the secant, the reciprocal, would have been just a 2. Okay, let's look at the next one. I have sine functions on both sides. Whenever you're solving an equation, even if it's a trig equation, you don't want your trig functions on both sides of the equation. So I'm going to start off, I have to add a sine of x to each side. So that way, I only have the sine on one side of an equation. 1 sine of x plus 1 sine of x is 2 sines of x. Plus I have my square root of 2, and it's equal to 0. Okay, now if I want to isolate the sine of x, minus the square root of 2 over. So 2 times the sine of x equals a negative square root of 2. It was positive here, so when I moved it over, it becomes a negative. Divide by the 2, because this is 2 times the sine of x. So in order to move it to the other side, I would have to divide. So I have my sine of x isolated. That means it's time to go to the unit circle. The sine is the y value. So where on the unit circle is the y value? Negative square root of 2 over 2. My y value is negative, meaning I'm going to go to the quadrants that are below the x-axis. I'm looking for negative square root of 2 over 2. So I do see one at 7 pi over 4. If I keep looking at the y values, here's another one at 5 pi over 4. Both of those locations, your sine or y value is negative 2 over 2. So those would be the two solutions for number 4. So x equals 7 pi over 4 and x equals 5 pi over 4. Okay, here's one more of, we're going to call these the basic equations, okay? If I have a tangent of x, again, you want to isolate the trig function. So I'm going to start off, I will minus the square root of 3 to the other side. Now remember, tangent is y over x. So I may have to try a couple of these where I take the y value divided by the x value because I want my ending solution to be negative square root of 3. However, I can narrow down the quadrants because the tangent is positive in quadrant 1, it's negative in quadrant 2, it's positive in quadrant 3, and it's negative in quadrant 4. So by knowing where your tangent is positive and negative, before you even look, you can narrow it down. I can look in quadrants 2 and quadrant 4. Okay, so I'm going to go ahead and look. I want to be able to take the y value divided by the x and end up with a negative square root of 3. So if I look, I'm going to go ahead and look at quadrant 2. I know that I need a square root of 3. So the first one that I run into is 2 pi over 3. So if I take this ordered pair and I try it, if I take the y value, and I'm just going to mark this as 2 pi over 3 so I know what I'm testing. The y value is the square root of 3 over 2. Divided by the x, both of them are fractions. So instead of dividing, I'm actually multiplying by the reciprocal of x. It's a negative 1/2, so the reciprocal is negative 2 over 1. The 2 cross cancels the 2. Positive times a negative is a negative. Square root of 3 over 1 is a square root of 3. So when I tried the x and y value from 2 pi over 3, I did end up with what I need. That means that x equals 2 pi over 3 works. Now the other thing, I know I can have a solution in quadrant 2, which we found, and in quadrant 4. So if I compare those, you want your x and your y's to be the same values in the same location. What will change is the sign. So I know that this worked. It worked when my 1/2 was first, followed by a square root of 3 over 2. So if I come down here, I want the one that has the 1/2 first, followed by a square root of 3 over 2. So my other solution would be 5 pi over 3. And again, you could always go ahead, take the x and the y values, take y divided by x, which is the same thing as y times the reciprocal of x, just to make sure. Okay, so again, here were 5 examples of just the very basics. Now they're going to move into some tougher things. So this is kind of like an intro. Again, we are going to spend a few days on this section. This is called a multiple angle. And what that means is in front of x, it's not just an x. You're going to have a number here. Sometimes it's a 2, sometimes it's a 3, other times it's a 4. You might have 1/2, and they could show that as x over 2. But what you want to do is still isolate the trig function. Okay, so that's where we're going to start every single time. How do I get that trig function all by itself? Step 1, I would add the 2 over. So 4 times the cosine squared of 2x equals 0 plus 2 is 2. This is 4 times the cosine, so I need to divide by 4. So cosine squared of 2x equals 2 over 4 can be reduced down to 1/2. Now, in order to cancel a square, you take the square root of each side. Anytime you take the square root in order to cancel a square, you have to include both the positive and negative of the other side. So what this is going to do is double the amount of solutions we have. So you can have 4 solutions, 6 solutions, and you'll see some coming up where we do. We have quite a few. So it's plus or minus. If you take the square root of a fraction, remember it's the square root of the top over the square root of the bottom. Square root of 1 is 1. Square root of 2 is the square root of 2. I can't leave it like this, so I have to rationalize the denominator. So cosine of 2x equals plus or minus square root of 2 over 2. Okay, now you start the same way. We have to look in the unit circle from 0 all the way to 2 pi. Where is the cosine, the x value, positive or negative square root of 2 over 2? Okay, so any x's that are a positive or a negative square root of 2 over 2. But instead of saying x equals that, that's what 2x equals. So we're going to go ahead and look for these. So x, square root of 2 over 2. So 2x equals pi over 4. 2x equals, again, I'm looking for x values that are square roots of 2 over 2, positive or negative. There's 3 pi over 4. And I'm telling you, we're going to have 2 more. So keep going around. You look through the whole circle. There's an x value, square root of 2 over 2. That's 5 pi over 4. We've gotten 1 out of quadrant 1, 2, and 3. So hey, guess what? Let's go to quadrant 4. X value, square root of 2 over 2 is 7 pi over 4. So notice what happened here. It is a plus or minus square root of 2 over 2. Okay? It's a cosine. So I had to look on the unit circle. The difference is this is not just a single x. This is 2x. So when I find those values on the unit circle, they are equal to 2x, not just x. And what that means is I'm not done. You have to isolate the x. So if I divide a 2, you can't divide fractions. So instead, when I'm really dividing a 2, what you have to make sure you realize is that you're multiplying by 1 over 2. Because it's the same thing. Dividing by 2 is the same thing as multiplying by the reciprocal. So your answer here would be pi over 8. Here again, if you go to divide by 2, that's the same thing as multiplying by 1/2. So you isolate the x. This is 3 pi over 8. Divide by 2, same thing as multiplying by 1/2. This is 7 pi over 8. Divide by 2, same thing as multiply by 1/2. This is 5 pi over 8. This problem has 4 solutions. Your solutions are the ones that I wrote in black because you did have to get x by itself, but you don't do that until the very end. Once you have isolated your trig function, that's when it's time to go to the unit circle. So we had to go to the unit circle once we knew that we were looking for cosines, x's, that were positive or negative square root of 2 over 2. We just had to take those values equal to 2x rather than a single x. Okay, so there's one example of what's called a multiple angle. All right, let's look at number 7. So number 7, we're dealing with a secant. You always want to get the trig function by itself. So step 1, I'm going to add 2 to the other side. Square root of 3 times the secant of x equals 2. Go ahead and divide both sides by a square root of 3. So a secant of x equals 2 over the square roots of 3. Now, when you're looking at a unit circle, we don't have like a little, hey, let's find the secant. Remember, the cosine is the x, the sine is the y, and the tangent is y divided by x. So when we get cosecants and secants and cotangents, the easiest way to do this is to remember this is a reciprocal to what function? A secant is a reciprocal to the cosine. So that means the cosine is going to be the reciprocal of whatever the secant is. So the square root of 3 will go on the top, the 2 will go on the bottom. So I still isolated the trig function. I just had to know that the secant is the reciprocal of the cosine. I could flip that upside down. Now on my unit circle, I'm looking to see where are all of the locations where the x value is a positive square root of 3 over 2. The x value is positive, so I'm going to travel to the right. Square root of 3 over 2, so it's pi over 6. There's 1. Looking for x values, that's square root of 3 over 2. Oh, there's 11 pi over 6. And I know that I won't have any in quadrants 2 or 3 because that's where my cosine is negative, and we're looking for a positive square root of 3 over 2. Let's look at another one. If I want to isolate the trig function, I want cosecant of x all by itself. First step, move the minus 2. So cosecant squared of x, I would add 2 to the other side. That's how it's positive. To cancel a power of 2, you need to take the square root of each side. Square root cancels a square. Cosecant of x equals, I cancel the power of 2, so don't forget it's plus or minus square root of 2. Now cosecant is the reciprocal of the sine. So that means that the sine of x equals plus or minus 1 over the square root of 2. I can't leave it like this. I would rationalize the denominator. So sine of x equals plus or minus 1 times the square root of 2 is the square root of 2. Square roots of 2 times the square root of 2 is the square root of 4, which equals 2. So now it's time to go to the unit circle. The sine value is the y. Y tells you if you're going up or down. This time I can look for positives and negatives. Typically when this happens, you'll be looking for solutions in every quadrant, okay? You're looking for wherever the y is some form of a square root of 2 over 2, whether it be positive or negative. So y values, square root of 2 over 2, there's 1 at pi over 4. There's my solution from quadrant 1. Now go to quadrant 2. Where is the y square root of 2 over 2? Oh, 3 pi over 4. X equals 3 pi over 4. Moving right along, let's go to quadrant 3. Look for the y values. Here it is. Negative square root of 2 over 2. I have 5 pi over 4. Let's go to quadrant 4. Where can I find a y value, because we're looking at the sine, with a square root of 2 over 2? Right here, 7 pi over 4. So here are 4 solutions within a unit circle where the sine, the y value, was either a positive or a negative square root of 2 over 2. One more like this, and then we're going to jump to some quadratics, okay? If I have a tangent here, I need to isolate the tangent. So step 1, add 1 over. So 3 times the tangent squared of x equals 1. It was 0 here. To move my minus 1, I had to add it. Now if I divide by 3, tangent squared of x equals 1 divided by 3. To cancel a power of 2, you take the square root of each side. Square root cancels a square, so tangent of x equals. I cancel the power of 2, so it's positive and negative. The square root of the top is 1. The square root of the bottom is 3. If I multiply top and bottom by the square root of 3, this is what we're looking for. Tangent of x equals plus or minus square roots of 3 over 3. Now remember, tangent is y over x. I can look at all 4 quadrants because I'm looking for anything that's positive or negative where I get the square root of 3 over 3. Okay, so if I go back and look at the notes, we did have one earlier where we were looking for the tangent of square root of 3 over 3. Okay, and we were able to find those. We just kind of tried a couple things. And the solutions that you would find using your unit circle, just to kind of save us time so this video doesn't go so long. Pi over 6 would work. 7 pi over 6 would work. 11 pi over 6 would work, and 5 pi over 6 would work. So what you're doing here for number 9 is you're doing the exact same process that we have for 6, 7, and 8 as well. So you isolate the trig function. We did have to rationalize the denominator. The reason why it's positive and it's negative is because I had to use a square root to cancel a square. You're going to look on the unit circle anywhere where y divided by x would have you end in a square root of 3 over 3. Because it's plus or minus, you will be able to find one in each quadrant. So it is the same process. Again, tangent, you're just looking for y divided by x. Okay, moving on. The quadratics in the sample problems above, they only involved one trig function. Okay, it was either a cosine or a cosecant or a tangent or a secant. But the deal was you only had one. If you have 2 or more functions that occur in the same equation, what you need to do, step 1, collect all of the terms on one side. You want all of the trig functions, whether they be the same function or different functions. You want them all on the same side. Okay, then you try to factor. You may need to use some of those identities that we've been practicing with as we've been verifying and simplifying to simplify things down a little bit. What you're doing ultimately, though, is creating factors. So you're going to factor it as far as you can. Take each factor separately, set it equal to 0, and solve. It is possible that some factors have no solutions. So if you end up with something like the sine of x equals 5, if you go to your unit circle, the sine is the y value. If it says the sine of x equals 5, if you look on this unit circle, there are no places where the y equals a 5. And so in that case, you would not get a solution out of that factor. So just so you know that it is possible now at this point where you're going to have some things that don't work, and that's okay. All right, let's go ahead and try some. So number 1, collect all of the terms on one side. So what that means is I have to take this 2 times the cotangent of x and I need to move it to the other side. So I have cotangent of x times cosine squared of x minus 2 times the cotangent of x equals 0. That's what that means. Have all of your terms on one side. Now see if you can factor. I can factor here. This term has a cotangent, this term has a cotangent. So both terms have something in common. I can divide out the greatest common factor. That would leave me with cosine squared of x minus 2. Now this is factored. So you take each factor. Cotangent of x, you set that equal to 0. Cosine squared of x minus 2, you set that equal to 0. Now you have 2 equations. Cotangent is the reciprocal of the tangent. Tangent is y divided by x. So what I'm doing is looking and saying, where is x over y equal to a 0? So I'm looking for x's to be 0 and y's to have a numerical value. So here, pi over 2. X over y, 0 divided by 1 is 0. So one solution is pi over 2. We want to look and see if there's another location where x divided by y is 0. And if I make it all the way down to 3 pi over 2, 0 divided by negative 1 is 0, so x equals 3 pi over 2. Okay, so I was able to find two solutions for the cotangent of x equals 0. Now I need to isolate cosine of x here. So I add 2. Cosine squared of x equals 2. To cancel the power of 2, you take the square root of each side. This is the cosine of x equals plus or minus, because I canceled the power of 2, square root of 2. So now you look on the unit circle, where is the cosine, a positive or a negative square root of 2? Yep, if you don't see one, that's perfect, because there is no location on a unit circle where the x value is just a positive or a negative square root of 2. So you do not get any solutions out of this factor. You only had two solutions to this problem, pi over 2 and 3 pi over 2. Let's go ahead and look at the next one. Step 1, you want all of your trig functions on the same side. So I would start off by minusing the tangent of x over. So 3 times the tangent cubed of x minus tangent of x equals 0. Now you try to factor if you can. Both of these terms have a tangent. So tangent of x can be factored out, leaving you 3 times tangent squared of x minus 1. I took out one tangent, so this went from 3 down to 2. Tangent divided by tangent is a 1. Now these are my two factors. So you take each one separately equal to 0. Tangent of x equals 0. 3 times the tangent squared of x minus 1 equals 0. Tangent of x. Tangent is y over x. So now we're looking on the unit circle. Where can I take the y value, divide it by x, and end up with 0? So here at 0, 0 over 1, well, that would work. So x equals 0. That's a solution. If I go ahead and look at the next one. Okay, so y divided by x. Ooh, y divided by x. You want it to be a 0. 0 divided by negative 1 is 0. So far I have 0 and pi. Where else can I take y divided by x? Oh, I get all the way back here. Now I already used the 0. So you can't use it again. Remember, you use the 0 versus using 2 pi. Okay, now let's go to the next one. If I add 1, 3 times tangent squared of x equals 1. Divide by 3. Tangent squared of x equals 1/3. Take the square root of each side. So tangent of x equals plus or minus. The square root of 1 is 1. Square root of 3 is a square root of 3. Rationalize the denominator. So now you need to find tangent of x. Where is y divided by x equal to a square root of 3 over 3? Okay, so this is what you're looking for on the unit circle. Because it's positive and negative, that's your little indicator that you're going to actually get 4 solutions out of here. When it's plus or minus, you're going to end up with a solution in every single quadrant. So again, we did look at this one earlier, where you can get square roots of 3 over 3 at pi over 6, at 11 pi over 6. We can get that at 7 pi over 6 and 5 pi over 6. So this particular problem, you guys, we had 6 solutions to this, which is kind of crazy. So I had to go ahead, move the tangent over. I could factor because both of my terms had a tangent. Once it's factored, you take each factor separately equal to 0. You isolate the trig function. Here it was already isolated. So I just had to find on the unit circle where y divided by x was a 0. That gave me 2 solutions. Here, during the process of getting tangent of x by itself, I ended up with positive and negative square root of 3 over 3. Because it's positive and negative, I know that there's possible solutions in every quadrant. You want to look in every quadrant and say, where can I take the y value divided by the x value and end up with a square root of 3 over 3? That gave us 4 additional answers. So number 2 has 1, 2, 3, 4, 5, 6 solutions. It's kind of cool. Okay, we have a couple more and we will call it a day for our second week of distance learning. How's this for a Monday, guys? Okay, if I look at number 3, I already have my trig functions on the same side. You want to see if you can factor this. This has 2 cosines, this has 1 cosine. So I can divide out a cosine of x. That would leave me with the cosine of x minus 1. Once it's factored, take each factor separately, set it equal to 0. Now here, cosine of x is already isolated. Cosine is the x value. Where on the unit circle is the x value equal to 0? Well, I have 2 of them, pi over 2 and 3 pi over 2. So x equals pi over 2, x equals 3 pi over 2. Now here, I have to get the cosine of x isolated. So first, before I go to the unit circle, I need to add the 1 over. Cosine of x equals 1. So where on the unit circle do I have an x value that's equal to 1? There's only one spot. It's at 0. X equals 0. So this problem, I ended up with 3 solutions. Okay, so let's go ahead and look at the last page. Now this is quadratics. So this is tying in our skill of factoring. You can factor using difference of squares. You can factor using the multiply add method, any of those things. So it says factor to find all the solutions. I have 1, 2, 3 terms. If you have 3 terms, remember it's the multiply add method. I can take the first term times the last term because there is a number in the front. 2 times negative 1 is negative 2. You're adding to the middle, which is a negative 1. Those 2 numbers would be negative 2, positive 1, because negative 2 times 1 gives me negative 2. Negative 2 plus 1 is negative 1. Because of the number in front, these 2 numbers replace the middle term. The first term stays, 2 times sine squared of x. The last term stays, minus 1. The middle term was just a sine of x, so it's minus 2 with the sine of x plus 1 with the sine of x. Now I have 4 terms. If you have 4 terms, you use what's called the grouping method. You group the first 2 terms, you group the second 2 terms, and now we continue to factor. These 2 terms both have a 2 and a sine of x. So I would have a sine of x minus 1. I need this to match this. It already does. If it already matches, what you divide out is a 1, because I don't want to change it. When you're doing grouping, it's important for these 2 sets of parentheses to be the same thing. Now that they match, whatever you took out, that forms a group. So 2 times the sine of x plus 1 is a group. Sine of x minus 1, that is a group. Now you take each factor separately and set it equal to 0. So 2 times the sine of x plus 1 equals 0. You have to isolate the sine of x. So I'd minus 1 divided by 2. So sine of x would equal negative 1/2. So now you can go ahead and go to the unit circle. Where is the y value negative 1/2? 11 pi over 6. There's 1. The y value negative 1/2. The other one is 7 pi over 6. Now I go to the other factor and set it equal to 0. Sine of x minus 1 equals 0. So I'd have to add 1. So sine of x would equal 1. So now you can go to the unit circle and say, where is the y value equal to a 1? There's only one location, and that's at pi over 2. So x equals pi over 2. Here are your solutions to that quadratic equation. 2 more just to make sure that we've got it. I know it's new. It is kind of fun. It's a new week coming off of the weekend. We want to make sure that we understand right off the bat. Okay, same idea. There's 1, 2, 3 terms. So multiply, add. There is a number in the front. 2 times 1 is 2. The same 2 numbers have to add to a 3. So you're multiplying to a 2 because 2 times 1 is 2, adding to the middle number, which is a 3, so that's a 2 and a 1. 2 times 1 is 2, 2 plus 1 is 3. I keep the first term the same, 2 sine squared of x. I keep the last term the same, plus 1. The middle two terms, it's going to be a positive 2 sine of x plus 1 sine of x, because it's replacing a term that had a sine of x. Now I have 4 terms, so I can use the grouping method. These two terms both contain a 2, and they both have a sine of x. If I take out the 2, that's gone. If I had 2 sines of x and I take out 1, I just have 1. 2 sine of x divided by 2 sine of x is a 1. These two things need to match. They already do. So what I need to take out is just a 1 because I don't want to change it. This matches this, so I can say that I have successfully factored it. 2 times the sine of x plus 1, that forms a group. Whatever you were able to divide out. What they have in common, that is your second group. Now what we have to do so we can solve is take each group separately. 2 sine of x plus 1, you set that equal to 0. Sine of x plus 1, set that equal to 0. Now we're back to like the very first idea for the day. Before you go to that unit circle, you have to isolate the trig function. So here I'd have to minus 1, then divide by 2. So the sine of x would equal negative 1/2. The sine is the y value. So I need to find spots where the y value is a negative 1/2. 11 pi over 6 is a solution. Again, I'm looking below the x-axis, so I'm looking at quadrants 3 and quadrant 4, where my sign is negative. Negative 1/2 and 7 pi over 6. Now if I look at the other equation, here I'd have to minus 1. So the sine of x equals negative 1. The sine is the y value. In the unit circle, where is the y value equal to a negative 1? Right here at 3 pi over 2. Are you guys understanding? Okay, good. I'm seeing some knots. Or I'm hoping that I'm seeing some knots. All right, let's go ahead and do one more, guys, and we will call it a day for day 1 of week 2. Let's go ahead. I have 1, 2, 3 terms again. 3 terms is always going to be our multiply add method. Again, just to make sure that we're confident with factoring in this manner where you have that number in the front. That's why I did that for all 3, just because I know for some of you this is still kind of tricky, okay? If I take 2 times negative 1, remember it's always the first number times the last number, that's a negative 2. You add to the middle. So if I have a positive 2 and a negative 1, 2 times negative 1 is negative 2, 2 minus 1 is 1. These are the two numbers that are now going to replace the middle. The first term never changes, so it's 2 times the cosine squared of x. The middle is now a positive 2 cosine of x. It's plus because the 2 is positive. Minus 1 times the cosine of x. It's minus because this is a negative 1. Minus 1. There's your 4 terms. Go ahead and group them. I can divide out a 2 and a cosine of x. That would leave me with 1 cosine of x plus 1. I need this to match this. Well, the cosine of x matches and the 1 matches, but what's different is the signs. This is negative, this is positive. This is negative, this is positive. So I don't want to change the value. In order to just change the signs, you divide out just a negative 1. So that would become cosine of x plus 1. These two match, so whatever I divided out, that becomes a group. What they had in common, that is a group. Now to go ahead and solve, you take each group. 2 times the cosine of x, and you set it equal to 0. Cosine of x plus 1, set it equal to 0. Now we're back to the very, very beginning of today's idea. Isolate the trig function. Add 1, divide by 2. So cosine of x is 1 over 2. So on your unit circle, where is the x value? 1/2. The x value is 1/2 at pi over 3. There's one solution. The x value is also 1/2 at 5 pi over 3. Now here, I need to isolate the cosine of x. So if I minus 1, cosine of x equals negative 1. Where on your unit circle is the x value negative 1? There's only one location, and that is at pi. So this is our beginning of 5.3. How do you solve trig equations? I hope you had a good time today. Again, if you did not bring a paper copy of your unit circle home, don't worry about it. As long as you have your textbook, open up that back cover and you will find a unit circle there. The suggested assignment, just so you can get used to this, I did say 1 through 32 all. There will be a Zoom meeting where you will have an opportunity to ask questions if any of these were confusing for you. But again, I hope you're doing well. Miss you much. Enjoy working on 1 through 32. Talk to you later. Bye-bye.